Oh, whoa, whoa, whoa. Yeah, my bad. X equals 6. It's early.
Okay.
I got that.
So let's try another one here. Um, 7 over n equals 8 over 7.
7 times n equals 8 times 7. N equals 8.
No, you got to you got to diagonally multiply. You got to diagonally multiply here.
Oh, I had it set up 7 times n equals 8 times 7. That's,
Yeah, we can't make up our own rules. It's
you're
not
right.
like, Michigan football. You can't just steal everyone else's signs,
Mhm.
allegedly.
Okay, so 8 times n equals 7 times 7.
Okay, so keep going. And
Is,
sometimes it doesn't work out.
yeah, what if it doesn't
Sometimes
go in evenly?
you just leave it as a fraction.
Okay,
So n equals 49 over 8.
yeah,
And that is it.
got it.
Okay, here's another one. If you're not drawing these diagonals, please do. Like show the
X equals 15.
9 times 10 equals 6 times x. 90 equals 6x. Divide by 6, divide by 6, x equals 15.
Mhm.
Okay, now a little more of an algebra review here. How would you simplify something like this? 4 times x plus 1.
We would carry the 4 into the equation and do 4 times x.
Tell me the result. Yeah,
Oh,
keep
okay, the
going.
result. Well, it's 4x plus 1.
You got to multiply both, though.
Sorry, 4x plus 4.
All right, good. Okay, so why does that matter? Let's look at another problem here. So when you diagonally multiply this time, it's 10 times b plus 5 equals 5 times 7 or 7 times. So it depends on how you look at it. It doesn't really matter. But the main thing I want you to see is that this b plus 5 is really in parentheses, and you're multiplying it by 10. So it's 10 on the outside.
Oh, I see.
Go ahead and distribute that 10. And then
Yep.
this is now an equation you
So now we
need to
have
solve.
10b plus 50 equals 35. So now solve this.
Yes. And you may not get like a nice friendly number. I like the word friendly.
Yeah.
Um, you may get fraction, a decimal. That's okay.
Negative 1.5.
Equals negative 1.5. Good. All right, so here is another one for you to try. Question?
Very close. Oh, wait, did you say question?
Yeah, do you have any questions for me on this, or you got it?
I think I got my answer. But 5.6.
Okay, let's take a look. 9 times b minus 1 equals 6 times 7. 9b minus 9 equals 42.
Yep.
That's looking close to what you have.
Yes, sir.
All right. So then you add 9 to both sides. 9b equals 51. And then you divide by 9. Now 51 is divisible by 9, or by 3. Sorry, by 3.
Oh, so we just
17 over
reduced this?
3. Yeah.
I see.
And that's preferred to. Now, will your teacher accept calculator, numerical approximations? I have no idea. Maybe.
Yeah, maybe.
Um, no, but that's up to you. So
If you
let's
can
let's
reduce it, just reduce it.
yes,
It's
and we can talk about the divisibility rules, but I think what would be better for you is if you did have a calculator handy and you just started dividing by like 2 or 3 or 5 or 7. These are prime numbers, by the way, and they both have to work.
Got it.
Here's a new one for you to try, please.
M equals 9.
That does work. Okay. So they just kind of get a little bit more challenging here. Now, the next style of problem you're going to see, we'll work out a couple of these together here. That one, if that one works out. So here's the next style of problem that you will see. It looks more complicated, it kind of is, but it's still the diagonal multiplying thing here. Okay, so it's 9 times p plus 10 equals 8 times p minus 7. You'll notice I really like to put that coefficient in front. That's where you're used to seeing it. So if you're not writing it there, I'd recommend trying to do that.
Okay.
Is that clear?
Yeah, that's where I
Okay,
was, like, that
excellent.
makes the
And then
most sense to me.
you distribute in and you get variables on both sides. So as a reminder here, when you have variables on both sides, okay, you move from the smaller to the larger.
Okay,
And in terms, again, like what's smaller, what's larger? If you think about a number line, smaller is over here on the left, larger is over here on the right. So if you have like 3 and 7, obviously 3 is smaller than 7. But if you have
right,
-3 and -7 is smaller than -3. Now, none of that applies here because you got 9 and 8, but maybe in
yeah,
a later problem it will.
okay.
All right, so give that a try, please.
So I've got one P equals -146.
Yeah. And I mean, sometimes the answers don't like,
Totally makes sense.
well, yeah, they're just numbers. I mean, these are just
Yeah.
made up problems to annoy students. But all right, here we go. Let's have you try another one here. Um, Appreciate your willingness to do kind of these worksheet problems with me today. It will help you
Yeah, no,
with the
I'm
rest.
good. I like this.
Yeah.
I have -20 over 3n.
Okay. So did you diagonally multiply like 2 times n minus 4, 8
Yeah.
times n plus 4?
Hmm.
Okay, so 2n minus 8 equals 8n plus 32. Do you have that?
Yep.
Okay, which is smaller, the 2n or the 8n?
2n.
So you subtract 2n from both sides. Let me know where you're different. Minus 8 equals 6n plus 32.
Yep.
Okay. All right. Okay. So I see I see now what you're telling me. This becomes -40 equals 6n. Now you divide by the number in front of the variable. What is
Oh,
the number
so
in front of the
I
variable?
wouldn't try to reduce this one. I would just try to divide this.
Well, no. You said your answer had you said an n on the bottom. I don't know if you meant that or not, but yeah, now you try to reduce this fraction.
Oh,
So
so
n is minus 40 over 6. You know, if this were a 10-point problem, I'd probably give you 8.5 out of 10. I mean, you got to reduce. So like
mhm.
you always start with 2. Does 2 go into, so try to divide both the top and bottom by 2.
Yeah, you can.
You can. What does that reduce to?
-20/3.
All right. That's the answer. Okay. Let's try a couple more of these. Um,
We got 97/3, and I don't think 3 goes into 97.
it's the divisibility rule for 3 is, do the digits add up to a multiple of 3? Is 9 plus 7, which is 16, a multiple of 3?
No.
So it does not work, but that is the correct answer. All right. Now there's a touch more difficult problem, which I have no idea if your teacher will give you. Um, so kind of the basic one here is 9 over x equals x over 16. So when you multiply diagonally, this time you get 9 times 16 equals x times x. 9 times 16 is 144. X times x is x squared. Okay. Do you remember how to solve something with an x squared? How to undo the square?
I don't fully remember now.
So you take a square root of both sides.
Oh,
And
okay.
140 square root of 144 is 12.
So would
The
that just be x equals 12?
or negative 12, but usually they want the positive one. So
Okay.
we'll um let me see if I can find a couple more like that. They don't tend to emphasize these as much, but then we'll move on to some actual triangle problems. Um, wow, I'm struggling here to find any that work that are like this. Um, all right, here's one like that. It's multiple choice.
Wait, I must be missing a step here. Where does this?
Oh, actually, there is no square root in this one. I'm sorry. I saw something different when I looked at it. Yeah, that I was just stalling to find some more problems, but let's move on here. So let's talk about triangle ABC being similar to triangle XYZ. So here's ABC. Here's triangle. That's drawn very poorly. XYZ. Now, what's the first thing you notice about these two triangles, if anything? Do you see anything that stands out to you?
XYZ pretty much looks the same, except it's upside down.
Yeah, so the thing that does not matter is like the orientation of it, like
Hmm.
whether it's rotated or flipped or on its side or yeah, so on and so on. So what matters here actually is not the triangles themselves, it's the letter order. All right. So I don't know if you've covered this in class, but the letter order is extremely important. It tells you a bunch of things. It tells you that angle A is congruent to, not congruent, I'm sorry, is congruent to angle B. Okay. And then angle, sorry, we're really off this morning. Angle X. And then angle B is congruent to angle Y, and angle C is congruent to angle Z. So the angle congruence is AAA is similar triangles. Okay. And it's actually only AA because the third angle is called the no choice theorem.
Hmm.
You don't need to know any of that. What you need to
Okay.
know is that
Then why?
the sides are what matters. So like AB is similar to XY. Do you see how A, B follows A and Y follows X
Yeah.
in the order? So then similarly, BC is similar to YZ. C back to A. So if you start at C, letter C and go back to A here, that's similar to Z back to X. Okay. And then the order also like you can also go in a different order. Like let's say you want to go C to B. So you're starting with the third letter, you're going to the middle letter. It's similar to Z to Y. And then like B to A, B goes to A, Y goes to X.
Got it.
Okay. And then A goes to C, uh, and then like X goes to Z. So it's all about the letter order. That's what matters here. So there's always you're like, well, what is that? Why does it even matter? So because you can't go by what you see. You can't assume things. You have to use the letters. Okay, now we're going to set up a proportion in all of these triangles. Okay, so RS, RS is the second two letters.
Right.
So it goes with U to V. So that 54 goes with U to V, which is 36. Now you have a choice. You can either choose to make like the first proportion one triangle and the second proportion the other triangle. That's what a lot of students do. But the letter groups that go together have to go in the same position. So this R to Q, which is the first two letters, but it goes with U to T. So R to Q is the first triangle. So I'm going to put that underneath the 54 from the first triangle. Okay, and then the U to T is the X plus 5 here. Now you could just guess and probably get it right, but you won't in the more complicated ones. So now this problem is like the ones we were doing. You have to be able to solve this proportion. You remember how to solve this from earlier today?
Yeah.
Okay, so you can take that 54 times X plus 5 equals 24 times 36. Go ahead and see if you can solve that for X, please.
Got X equals 11.
Okay. Now let's say I wanted you to find UT. Could you do that? The length from U to of UT.
16.
Yes. So remember in all those problems we're doing with angles, like sometimes you find the value of X and then sometimes you have to put it back in.
Mm-hmm.
That's what's going on here. Any questions on that?
No, I think I got that.
All right. New problem. Okay. I want you to see if you can set up the proportion. And I suggest but don't worry about that right now. Just focus on, these four things and look back at the triangle letters to decide where they go. And if you need a hint or something, let me know, but give that a try.
We'll go on the bottom right side. I'm not.
Let's just start with x plus 8.
Okay,
So
yeah,
we're
that's what I
just
have. X
we're
plus
just gonna
8
put
there.
that there. So that's NP. So what does that go with on the other triangle? What two letters?
Wait, that was
RP.
NP. Okay,
Goes with
yeah,
RP.
NP, RP. So,
So that's 3x minus 9.
okay, that'd be on the top. All right.
Now, what I've suggested sort of is that use the first proportion for the first triangle and NP. So 24 is going to go down here. But before you just write something on the lower right, what is 24? Well, it's M to P. It's the first and the last letter. What's Q to P?
28.
28. Okay, so let's have you try solving this. You'll definitely want a calculator.
28. Okay. X equals 10.
You're good. All right, now this time you have to find both NP and PR.
Mhm.
Could you do that for us, please?
NP equals 80
You're
and
adding 10
PR.
plus 8. 10 plus 8.
Sorry, 18.
Good.
Got me. And then this one I would multiply, right?
Yes. You apply and then subtract.
21.
Good. Okay. And sometimes the reasonableness of your numbers, you don't really have a great way to know whether they're right or wrong. It's just a best guess at this point. Okay, so let's try another one here. Setting up the proportions really the key thing at this point for you. You're doing great at solving it. Again, what I recommend is kind of you think about the one on the left here is for triangle BCD. The one on the right is for triangle EFG, or yeah, BCD, FG, whatever. Don't worry about this. like pick a side. Doesn't matter which side you pick, but pick a side, and that gives you your two letters to match with your other two letters.
Mhm.
Let's see if you can come up with a proportion here for us, please.
All right, I've got one more I've got a question here.
Of course.
All right, so B to C and um, F to G would be like the first one, right? So I got 39 on top, and then on
Yeah,
the other side, I've got 4x plus 2.
good, good. Now,
But then,
I didn't know if this would be confusing or not, but you could build two proportions where you put the letters first and then the things.
oh, I
That's
mean,
also an
I think
option.
it's just a little bit easier to just go with the,
Okay.
yeah.
So what do you got on the bottom there,
But then
below
C to
39?
D, there's nothing like, so what would I
Right.
do
So
about
well, you can't use that. You have to use the other given one, B to D.
that?
You can't like choose what you want to use.
Mhm.
So B to D is with the first triangle, and then hopefully it goes with the other given piece. So what goes in the lower right here?
4x minus 5x minus 2.
Right. So BD goes with FE. Okay. All right. Could you solve that proportion for us, please?
X equals 6.
All right, good job. All right, so we're still kind of mostly struggling on setting up the proportions, meaning like that's the part that I think is the least clear. Um, you solving's great. You're not having any issues solving. A lot of students struggle with the solving. Um, that's good. Let's see if we can just set up one more here before closing out. So this one's got two overlapping triangles. It's got A, D, E, and then A, B, C. And sometimes you have to separate them like this to get it to work out where you can label things appropriately. Can you tell me the length of A to B based on the drawing over here on the left? A to
28.
B, 28, good. And then B to C is 2x plus 3. So sometimes you have to do this. Now setting up a proportion, AD 20 goes with AB 28. Well, actually, I'm sorry, we're not doing it that way. We're doing it the other way. 28 over 2x plus 3. So if you want to, if you have time later today, you want to solve one, here's one for you to consider. All right, we're going to stop there for today.